So I'm gonna spend the next 2 hours studying these libraries here. Let's start with sklearn. There's libraries here. Let's start with sklearn, TensorFlow, and Keras. And then let me open the spec functions. I think I'm gonna keep this on the other monitor, but I'm probably gonna be using these functions here to inspect. I've never used them in the past, so I'm not sure if they exactly how they work, but let's find out. Just wait for this thing to load. So inspect.get members, get all properties of methods. Inspect get source shows source code. So inspect get source. Let's go there. Let's see if this works. Inspect get class tree, gets hierarchy of classes. Get doc shows documentation, shows where file is located. Get file shows where file is located. Signature for knowing arguments of a function. Get full args spec for more detailed descriptions of args. Oh yeah, I think I'm gonna put a timer here because I'll take a break after 2 hours, I guess. Then maybe I'll come back later to watch videos or read the documentation. Spec.unwrap unwraps function.wrap unwraps on level. Damn, it's taking a very long time to load everything. Maybe I'll try to build a model as well. Try to do some Kaggle competition just to practice. I'm gonna try to do console.log because I never used that. Not sure if it's possible. Yeah, so yeah, doesn't work. So that should reprint. Check for random seed existing environment. So here it is, I guess. sklearn is a Python module integrating classical machine learning algorithms in the tightly neat world of scientific Python packages. NumPy, SumPy, Matplotlib. It aims to provide simple and efficient solutions to learn problems that are accessible to everybody and reusable in various contexts. Machine learning as a versatile tool for science and engineering. See scikit-learn.org for complete documentation. Import sys logging os random. So these are the libraries that it uses, I guess. Classification, regression, clustering. This is documentation. Preprocessing, feature extraction, normalization. I think this one is a good one to start. Scaling data of outliers. If your data contain many outliers, scaling using the mean and variance of the data is likely to not work very well. In these cases, you can use robust scaler as a dropping replacement instead. Uses more robust estimates for the center and range of your data. Scaling versus whitening. It is sometimes not enough to center and scale the features independently, since the downstream model can further make some assumption on the linear independence of the features. Centering kernel matrices, mathematical formulation. Let K be a kernel matrix of shape and samples computed from X, a data matrix of shape and samples and features during the fifth step. K is defined by this formula here. Is a function mapping of X to a Hilbert space. A center kernel K is defined as what is a Hilbert space? Mathematics Hilbert spaces allow generalizing the methods of linear algebra and calculus from two-dimensional and three-dimensional Euclidean spaces to spaces that may have an infinite dimension. Hilbert space is a vector space equipped with an inner product operation which allows defining the distance function and perpendicularity. So it's pretty much how each represents higher dimensional functions. Vector space equipped with an inner product operation, which is kind of hard to imagine. It's impossible to imagine actually from 3D paradigm. Which means that who knows if it is really correct or not. Reprocessing robust scalar. So yeah, I don't think I wanna do this. I think I just wanna keep looking at this stuff here. From config import, get config, set config, config context, logger, logging, get logger name. I need to understand then their methods better as well. But I'm not sure to search for that. Maybe I can use the get source statement. Generic release markers. Complete formatted version use Python arg. On SX, we can get the runtime error due to multiple libraries. Workaround issue. This variable is injected in the built-ins by the build process. It is used to enable importing subpackages of sklearn when the binaries are not built. Cannot determine type of sklearn setup type ignore, accept name error, sklearn setup false. If sklearn setup, this is the stuff that I don't understand. Is what does this even mean? It has to come from another function. So maybe that's a good idea. True. So get all members of method. Maybe I should try all of this. But this, it's not gonna work. So maybe it's like this. Yeah, maybe this will show. What I wanna know. If sklearn setup sees standard error, dot write partially import of sklearn during build process. We're not importing the rest of scikit-learn during the build process, as it may not be compiled yet. Else, distributor init allows distributors to run custom init code. For instance, for the Windows build, this is used to preload the vcomp shared library runtime for OpenMP embedded in the sklearn /.lib subfolder. It is necessary to do this prior to the import and show versions. All. So this all method is also something maybe inspect, not get, members. That I don't understand really well. So how can I search for this? What I need to know is how to find how Dunder methods work. You wanna listen to this while I search for things in PyCharm.
Hey everyone, welcome back to this second tutorial of this Expo series for Python programs. So in this tutorial, we're going to study about the data models and the methods, special magic methods, or you can say. So before starting that, I would recommend that you just follow this documentation here, and the link is docs.python.org/3/reference/data model.html. I'll be giving this link in the description below. So what basically are the special methods? So special methods or the Dunder methods, you can see like this underscore new underscore init underscore delete and so on. These basically are used for function overloading. So let me just explain it to you what I meant by that. Let's see guys that basically you have to find two variables, and in that variables you have x is equals to 10 and y is equals to 20. Okay, so now if I call this that print the value of x, you gotta notice this x plus y, and if I go on, okay, sorry, yes, you can see that basically I the value of 30 is being printed over here. So this plus operator basically it uses a Dunder method, special Dunder method called add, which goes like the underscore add. It goes something like this. So whenever you call this plus sign on any of the two operands, then this add the number comma a comma something like this, and you can say self dot a plus self
It's not going to explain
d
how it actually
dot
works.
add. I call this, then and if I run it, okay.
Maybe I can use the source code, but then I can't really call it directly. That's the problem. It's just showing the same stuff. Oh, it's because I'm not printing, obviously. Method wrapper, absolutes, full objects. So this is a wrapper. Now wrapper is a function that has other functions, I guess. So far, what I'm getting for this is that I need to understand better Dunder methods and wrappers. Seems like it's the missing thing for me to understand how everything actually works. So this is a giant list of all the methods inside the setup. I know what the file where the file is from the library, so I guess I don't need to use the method to find out. It's on these external libraries, then side packages, and then TensorFlow or sklearn. Request library might be useful as well to study later. I think I put it here. Selenium might be good as well. So here there are all the methods: covariance, cross decomposition, datasets, decomposition, assemble, experimental, external, feature extraction, custom process, inspection, linear model, manifold, matrix, model selection, neural network, reprocessing. The issue with this one I saw, I don't remember if I saw it on sklearn or other libraries like TensorFlow, but I didn't understand much because it had all these methods and it didn't really show the code from what I remember. Yeah, like this just uses a bunch of OS environments on the init method. Try sklearn setup. Yeah, this is the file that it was showing there, I guess. When I did inspect.getSource. Let me see what this prints. Pretty much the same thing as the other one. So maybe if I do inspect dot unwrap. Now it goes one level higher, I guess. Because probably these are a bunch of nested functions. And I think unwrap goes one level higher. And calibration cluster, covariance. These are the files, I guess. So I think the get members is all the list of the functions inside of all these files, which are a bunch of wrappers. And if I do, I think this unwraps, the unwrap method I used before unwraps all the levels. I think this one unwraps the only one level. But it's not how it's written. Maybe it's like this. Dot unwrap. Dot wrap. It doesn't work. It's written function dot wrapped here, but I guess it doesn't work. So inspect dot signature. Get class trees. I guess this is not a class, so I can't do this really. Then get file. Yeah, now it works. So I guess I'll just look at these files one by one. By which one looks the most interesting. Then as I find functions, I'm gonna research what it means. It's probably the inspect is not really necessary unless I come across something that I think might be useful. Obviously I suck at this because I've never done it. But that's how you learn. So init I think is the initialization. Maybe if I search how to get source code from how to get Python source code. Watch this video first.
Hey everybody, how's it going? In this video, we'll be learning about special methods that we can use within our classes, and some people call these magic methods. Now, these special methods allow us to emulate some built-in behavior within Python, and it's also how we implement operator overloading. So what I mean by that is, for example, when we add two integers together, so down here I'm going to print out 1 plus 2, and when we add two strings together, so I'm going to print out A plus B. If I run this code, then you can see that the behavior when we add two strings together is different than when we add two integers together. So the strings were just concatenated and the integers were actually added together. So depending on what objects you're working with, the addition actually has different behavior. And also, if we were to print out our employee instance here, then you can see that we just get this vague employee object. And it would be nice if we could change this behavior to print out something a little bit more user-friendly. And that's what these special methods are going to allow us to do. So by defining our own special methods, we'll be able to change some of this built-in behavior and operations. So these special methods are always surrounded by double underscores. So a lot of people call these double underscores dunder. So if you ever hear someone say something like dunder init, then they mean init surrounded by double underscores. So speaking of dunder init, that is a special method that we've already been using and are familiar with. And it's probably the first and most common special method that people use when working with classes. So just like we learned in previous videos, this special dunder init method is implicitly called when we create our employee objects here, and it comes in and sets all of our attributes for us. So let's take a look at some other common special methods. So two more common special methods that we should probably always implement are this dunder repr and dunder str. Now these are what are implicitly called anytime we run repr on one of our objects or str on one of our objects. And these are what we're going to use to fix our problem of printing out this vague employee object when we printed out our employee instance here. Now, I have an earlier video on the difference between these two methods, but in short, repr is meant to be an unambiguous representation of the object and should be used for debugging and logging and things like that. It's really meant to be seen by other developers. And str is meant to be more of a readable representation of an object and is meant to be used as a display to the end user. So let's go ahead and write code for these and take a look at the difference. So first, we want to be sure to at least have an repr method, because if we have this without an str, then calling str on an employee will just use the repr as a fallback. So it's good to have this as a minimum. Now, a good rule of thumb when creating this method is to try to display something that you can copy and paste back in the Python code that would recreate that same object. So for example here, if I was to come in here and return, so we would want this to be something that we could use to recreate this object. So I'm going to say employee, and then in quotes, I'm just going to put a placeholder there, and I'm going to do quotes again for the last name, and then I'll do this employee. Let's see, I'll take these out, and instead directly a Dunder if this works. So here I can just print out employee 1 plus employee 2. And if I go ahead and run that, you can see that when we added these two employee objects together, that it gave us their combined salaries. Now, if we didn't have this Dunder add method and I copied on our employee.
This doesn't talk about stuff I want to know. So pipeline might be interesting. Then we have config. Start with the config. So global config is an object. Assume. Also, this thing I'm not really sure how to look for it, but this underscore before methods. I don't know if it's a special thing or just some standard way that people do things. So boolean os environment.cat sklearn sum finite. Sklearn working memory. So maybe I can do this. I can search for these things. Spec get file. Yeah, but that doesn't work. That's the problem. So maybe I can do global config. But then I think it's gonna show me that file. That's the problem. Yeah. This kind of sucks. Maybe if I type this on here. I think it's getting a file somewhere on my computer, but I want to see where the file is. Yeah, whatever.
Hello and welcome to another video. I've actually shown this a bunch of times on stream and in other videos, but I figured I'd make a separate video for it. In this video, I'm going to show you how to find the source code for a Python module. And so without further ado, let's jump into it. Okay, so we're going to be, picking a random module name and then trying to find it. In this case, let's start with the argparse module. It's one that I use pretty often in CPython, or in Python in general, and does argument parsing. But sometimes I need to look at the source to figure out how it works. And normally in code you'll see import argparse, and then you'll deal with argparse like this. So we showed ellipsis there, nice. So the first way that I want to show you on how to find Python files and Python source code is if you've imported the module, you can just print out the module. So if we just do argparse here, you'll see that the module object tells you what file it comes from. So this is one way to do this. This is actually not the way that I usually do this, because it involves you'd have to start up a whole interpreter session and import the module and then print the module, and so there's a lot of steps to this. So I don't usually approach it this way. What I do is I view the documentation for the module, and you can do that by doing python-m pydoc. So what pydoc does is it'll import the module and scrape all the doc strings and all the functions and classes and stuff, and show you the documentation of that module. So if we do python -m pydoc argparse in Python 2, I don't know. Here's the source code of based on the source code of C.
He's just talking about how to get source code, but not the Python source code. If I look in the IDE, it's gonna show me. I think it's on the environment. The problem is that I'm using Anaconda because of the TensorFlow and the scalar. It only works with the earlier version of Python. Only have the earlier version of Python on Anaconda. Nodes.py. It seems interesting. This allows to make attribute access faster. Note that dict is still available. I'm not sure if this is what I'm looking for. I think it's on site packages also, actually. I'm not sure if this file is, yeah, site packages. And the issue with this is you probably will have a bunch of system related stuff because it has to. So I'm not sure how much I can show on stream. Might be dangerous to show random files. This class exists to allow virtual environment creation to be customized. The constructor parameters determine the builder's behavior when called upon to create a virtual environment. By default, the builder makes the system global site packages there unavailable to the created environment. If invoked using the Python M option, default is choose copying on Windows platforms but syslink elsewhere. Instantiated some other way, the defaults should not use syslinks. Param system site packages. If true, the system global site packages there is available to create an environment. So let's see, they need system site packages false here. Def create. I think this is a virtual environment stuff. Maybe this is a waste of time to search for the source code. But that's an interesting question. How is Python or any other language written?
I'm Dutch. I grew up in the Netherlands. In fact, I created Python while I was working in the Netherlands. I got a nice job as a programmer at a place called CWI, which is sort of a research lab funded by the government doing advanced math and computer science research. My first job was on a team that worked on a programming language named ABC, and it was a super interesting project, and everything I know about language design, or all my opinions about language design, originate in that project. ABC was eventually unsuccessful, and I moved on to programming on other projects at the same place. The key one was Amoeba, which was a distributed system that was being built collaboratively by CWI and one of the universities in Amsterdam. At some point I realized every application we have to write in for Amoeba is basically a shell, either a shell script or a C program, and I found that there were downsides to either of those. And I thought, well, I wish there was a third language that was sort of in the middle of those, that felt more like a genuine programming language, like on the C side, but that was perhaps interpreted, easier to use, sort of more concise of expression, like shell scripts, but without the sort of terrible properties in terms of readability of shell scripts. I thought, I can build my own. Building an interpreter is going to take me 2 or 3 months, and I'll win that time back by increased productivity, not just for myself, but for the whole team. Well, those 3 months sort of ballooned to more and more time. I don't think on the Amoeba project, we ever gained that productivity back. Amoeba sort of mostly produced scientific papers. Python slowly became successful. And after about a year, we released it as open source. Actually, we didn't call it open source because those terms had not been invented. And almost immediately, a small community of Python lovers started growing, where people sort of spread the word about Python and sort of started contributing back and critiquing each other's contributions, and sort of let me have the last word about whether I wanted a particular contribution in the language. Last July, I actually resigned my position of BDFL, which is ironic because of the FL standing for life. One imminent change is that Python's own governance structure is changing. The community is currently in the middle of sort of figuring out what the best way is to sort of have governance going forward, which is either going to be another BDFL, although that is the less likely solution. More likely, I see a small committee of people who are committed to Python's success long term. Those people will also be guiding Python's sort of future vision.
It's crazy how much coding there is here. Yeah, that's crazy. Slice and piece parse parallel job lib. The list of things just keeps increasing. Transformer mixing, utils. The search utils as well. I'm not sure if that's the Python library there, the lib that I opened, but I'm not sure if this is a waste of time, but it seems like it is going to help me understand everything. And apparently it was written in C. I'm gonna watch one more video about this.
Today, Python stands as one of the world's most popular programming languages. It ranks at number 5 on the TOB index and can safely be named the number 1 scripting language, as no other scripting language is ranked higher. But it wasn't always this way, so how did Python come about? Python isn't exactly a new concept. It was conceptualized by a man named Guido van Rossum in the late 1980s as a successor to the ABC programming language, another programming language created at Van Rossum's workplace, CWI, the National Research Institute for Scientific Research in the Netherlands. Much like ABC, Python wasn't aimed at systems programming and was designed to be easy to learn. But unlike ABC, Python included support for exception handling and was originally targeted at the Amoeba operating system. Now, the Amoeba operating system was a time-sharing system built at an Amsterdam university which, like time-sharing itself, has fallen out of favor. But Python lives on. Van Rossum started the actual implementation of Python over the Christmas holidays in 1989. It wasn't actually named after the snake, by the way. It was named after the British TV show Monty Python's Flying Circus. He continued working on it privately until February of 1991, when the first version, 0.9.0, was released. Python included many features of the language like classes, functions, and data types, such as lists, dictionaries, and strings, in addition to the aforementioned exception handling. Version 1.0 of Python came about in January 1994. One of the most notable new features was increased support for the functional style of programming, with tools such as Lambda, Map. Python was the perfect language for Van to learn. It most certainly is very popular as a first programming language to new programmers during Python was sitting at version 1.5 at this time. CNRI requested the request of CNRI, while Python was developed in a relatively closed fashion. With 2.0, Python became more like a standard open source project that would have a life after Guido. Python was moved to SourceForge, granting CVS access to more people and providing an easy way to submit patches and bugs. It was Python 3.0, sometimes called Python. Instead, Python 3.0 opted to
Damn it. Nobody talks about here. Python is written in some programming language. Since Python as a language is just a set of rules, like syntax rules, or descriptions of standard functionality. So I might say that it is written in English. However, mentioned rules can be implemented in some programming language. Hence, if you send a string like import this to that program called interpreter, it did return is the end of Python. Since most modern OS are written in C, compilers, interpreters for modern high-level languages are also written in C. Python is not an exception. Its most popular traditional implementation is called CPython is written in C. So it's written in C. So I guess the source code should be C code.
Hello everybody and welcome to this episode of Object-Oriented Programming. In this episode we're going to look at modules and packages and understand how Python allows you to structure big systems. So up till now we've created standalone applications, we've written a program in a file that has a class and methods inside it. But as we build up more and more classes and more methods and attributes, we need a way to organize it. How Python organizes things is every file that has Python code in it is called a module. And when we put a couple of different files, like notepad files, imagine notepad files in a directory, the directory is a package. And that means we can, if I have two files in the same directory or folder, I can call one file from the other. This is phenomenal. This is amazing. This is so much better than a lot of other object-oriented programming languages where you have to install class paths and change system variables and all kinds of crazy stuff. If I have a Python program and another Python program in the same folder, they can just talk to each other by calling the name of one together. That is great. It is ruinous to you, I think, in a way, because this is so easy compared to some other object-oriented programming languages. Anyway, we'll have to live with it, we'll cope with it. So when I use the term module, when I'm talking about is a Python file, a .py file, or when I say package, it's a folder with a bunch of .py files in it. So the benefits are obvious. Let's say I'm building an e-commerce system, and I have a single file that contains all the classes related to accessing a back-end database, we'll say, that's storing all the e-commerce transactions. And then I have other modules about products, about customers, about inventory, and things like that. They're all in the same folder. Each of them just needs to make a call to the database file, and that they don't have to make connections to the database themselves. It's just a single connection from the database file to the database. So this is a very effective and centralized way of dealing with connections and separation of authority and activities. So if I have a file or a module called point.docstrings.py, if I want to call that file, or rather if I want to call the methods or attributes or the class from that file into another file, all I just say is import point.docstrings. That's it. If the file is called banana and the class inside is called point, to import the point class, I need to say import banana. So I'm importing the name of the file. Okay, that's what the import means. It's look for a file with that name, point.docstrings.py, somewhere in this same folder. And then once I've imported it, if I want to declare an instance of point, I just say pointstrings.point and assign it to a variable name. So this is important to remember. What you're importing is the name of the file, not the name of the class. The class inside can be called, again, if the file name is called banana and the class inside is called point, I import banana, and then I can do banana.point. So if we look at it in code, it's simple as that. We say import docstrings, and then we can declare variables of type docstrings. We can put values into the points as before. We can print them out, and that works perfectly well. So if you want to have a go with that now, take the point strings code that we have, docstrings that we have done since for the previous lesson, and just create a new file calling point docstrings and have a run of this. In fact, the sample code on this page to do that, just to see that in action. Just to use a specific term, now that we've included point docstrings into the calling program, we said that point docstrings is part of that calling program's namespace. The namespace is the list of methods and classes and attributes that are available to a current program. So if I'm the calling program, if I say import banana, then banana is part of my namespace now. So whatever I have in my own code, all the methods and attributes classes I have in my file, plus any I import, they're all part of my runtime namespace. If we didn't want to import the whole file, because when we say import point docstrings, it's importing all the classes, all the methods, all the attributes. If we just want to import a specific class, and we've seen this before, we can just say from docstrings import the class point, and then we declare a point as before. And as code, that looks exactly as before from point docstrings import point. So when we're saying that, all we're saying is from a file or module is the Python term import a class, and then we can use the class to declare instances or create objects of that class. If by some unusual circumstance we already have a class called point in the calling program, let's say the calling program has a class called point in it, and I want to import a different point, but its name is point as well, we can import it as PT, for example. So the class name we're importing is point, but it's coming in as, it's being renamed as PT because there's already a class called point in our namespace already. So then we go P1 equals PT. So let's look at our code. It's simply that from point docstrings import point, but import it as PT, and then we declare instances of PT, which are the point method from docstrings. We could also import more than one class simply by saying from point docstrings import point, comma line, comma square, comma banana, whatever we want. We did use this a little bit in the last term, but we probably should avoid saying import star or from docstrings import star. A lot of Python programmers get very angry and confused when you do that because they don't know what specific methods you want from the point docstrings file or module. So it's as well just to specify which particular classes, in this case point and line, that you want from the particular module. Now let's look at how we organize the modules. So how do we organize the files within our folders? Because, you know, it would be nice to have all your Python programs in a single directory or folder, but it just gets confusing, so we need to start putting things in subfolders. We said a folder or subfolder is called a package, so we'll use the term package and folder or directory interchangeably, and we'll use the word module or Python file interchangeably as well. So let's say we have a folder called parent directory, and in that it's got a Python program called main. It's also got a folder called drawing, and in that folder it's got three files, init.py, point call, and point docstrings, and a folder as well called maths, and inside the maths folder it's got init.py and the theorem.py as well. in Python, when you're creating packages or subfolders, you always put an init.py file in each subfolder. We'll talk about that in a second. Yeah, absolutely. So the init.py lets you do stuff. There they are. So this is it. Same thing again. We've got drawing and main in the top directory, and then in parent directory drawing, we've got 2 regular Python programs, and then init, and then a subfolder called maths, and in the maths one we have theorem and an init file. For the moment, let's leave the init double underscores empty, and let's look at how we bring in packages. We've looked at one way, which we call an absolute import, and we'll look at a relative import. Absolute imports are how we've been doing them up till now. So what it means is we specify exactly where we're getting a file from. If we can say import a particular class by saying import drawing.pointCall, or from drawing.pointCall import point, or from drawing import pointCall. We'll remember that drawing is the name of the folder, and then one of the files in that folder is pointCall. So the folder is drawing, that's the package, and pointCall is a file in that folder called a module. And we can import classes from each file. Okay, just like that. So drawing is the package or folder, pointCall is the module or file, and then point is a class that we're importing from a specific file in a specific folder. That's an absolute, that assumes that the file I've written the code in is in a folder, the drawing is one of the subfolders directly underneath it. We can mess that around a bit by using relative naming. So what relative naming means is if I put in a dot in front of a package name, I'm saying it's in the current directory. If I put in dot, it means it's in the previous directory. Putting in a dot doesn't really matter, but anyway, we'll see it. So if we have our file structure again, and I'm in the file pointCall, and I'm talking to the file point.strings, then all I need to, I can say from either dot point, .strings, or I don't need to put the dot in, I can put it in or not, it doesn't matter because they're in the same folder. Whereas if I'm in the folder maths, and in the folder maths I have a method called theorem, or a file called theorem, and I want theorem to call the file point.strings, which is one directory up, then I need to say from dot, which means go one folder up from where I am, look for a file called point.strings.py, and then import point from there. So I hope that's clear. There is one thing we can use init.py for. We said leave it blank for the moment, but if I'm in a particular folder and I want to ask, well, if I want to ask for a specific class from a particular module, I can use init.py to do it. So if let's say we want to get the point class from the file or module called point.strings. If we're in the main directory, we say import drawing.point.strings.point. We could add the following phrase into init.py though, which is from point.strings import point. And that means I can say from the main directory, import drawing.point, instead of having to say import drawing.point.strings.point. So if it says it in the initialization file, we're going to be looking at the .strings file all the time here, and the point class is the one we'll be importing. Then I just need to say, in the drawing folder, get me the point, and the init file tells us it's in point.strings. And then, yeah, if all we have to say is just from drawing import point, which means from the folder, give me the class point. We don't need to specify module, because the init file tells us. So it's kind of like that file converts the drawing package into a module, or the folder into a file. That's kind of what it's like. So moving on now, let's look at organizing module contents, and more specifically, creating global objects. So inside of a module, we can specify variables or attributes, classes or methods. As well as creating global classes, we can also create a global object, though, which I want to look at in this example. So if we think about our e-commerce site again, it connects to a database, where we're saying, so good practice would say there should be one database class, and all the other classes connect to the database via the database class. Not only should there be one class, but there should be one object, because we can't have different classes being instantiated different database objects. So we need a single database object. Let's look at the case where there's multiple objects. If we have a module called database, and we have some implementation, and then in our database code, we say database 1 is assigned an instance of database. That means we create an object of type database, and we've given that instance object a name database 1. And that is a problem. So then in each of our other modules, in our product module, in our inventory module, in our customer module, we'd have code saying from e-commerce.database import database 1. The problem there is that then we're going to end up with multiple instantiations, multiple copies of database 1, which is definitely a problem, because then each one will try and connect to the database separately, and it'll cause a bit of a delay. So we prefer not to have these multiple connections. That'll slow down the process. Instead,
All right, what's up everyone? Today, we're back with another video. Last time, we talked about the init method, and I have that right here already. And if you haven't seen that video, watch that video to help you out a lot in this one. Today, what I want to talk about is the call method. It's a Dunder call method. You can see over here, like last time, we got what we're going to build over here on our left. We're going to try and expand upon the manager class a little bit, and you'll see how we do that. It's a bit advanced, but I think you'll follow along just fine. So what the call method is essentially turns your class or your object of the because as we learned from last time, the class is just the blueprint to build an object. So what it actually does with the call method is it makes your object act like a function, essentially. Lets you call upon your object. So we'll start off with a super simple example, but what we're hoping to make today is sort of like a way to keep track of people's pay a bit simpler or a bit more effective or efficient. So anyways, we'll get into it. You'll see what I mean in a bit. So over here on the right, as you saw before, we have the init method, right? So the call method is formatted similar, but you just pass in any parameters if it was a function, but you still need to pass in self. So, oh, let me just, I don't know what I'm doing there. I'm going to put in hours worked, right? So we'll just pass in a number very easily. So for now, what I'm going to do is just simply return. We'll print it. We'll print the hours worked, and then we'll just return them. So you'll get a good idea here. Okay, so pay equals pay. So as always, that first initialization is going to happen with the init. So we're calling the init like we learned in the last video. So let's just pass in an hourly wage. So for this person, or for this instance, we'll just do $15, and then
Crazy.
okay, so $15, and then what we'll do is to use the actual call method, you literally just treat the object. Remember this part, the left side here, that's the object we've created, right? So we're calling upon the object. Here, let me just make it a little easier. Pay test.
Well, it's because of his thing.
So we're literally going to call upon the object we've created and just pass in how many hours that person's worked. 8, right? And when we run this, we'll see 8 comes up. So, and it's printing out twice because we're printing it here and here. You'll see if I erase that. Just one time. So you can see how it's just passing in as if the object is a function. Now, how can that be beneficial? Well, you can see over here on the left that we can sort of start keeping track of things if we want, right? So we can say, hey, let's put in, and remember, these are class attributes, generally good for things that are just going to be hard-coded in. Like, for example, in this case, we're starting off at 0, so we might as well just hard-code in 0 and leave it up top there. And then you'll see that the class method now, what we're going to be doing is like tallying up the hours worked, tallying up the total pay for this person. Now you could take this exponentially further. You could start adding in like time period that they're paid. You can add in maybe even like pay periods or something like per month how much they're getting paid, year bonuses, blah blah blah. It's endless. You can just add as much stuff as you want, and I guess the idea with this class is going to be that it all keeps the information contained in this one unit, and it's just really it's a lot easier to work with in a sense. So you'll see here that now what we're going to be doing is keeping track of this, and you might think, well, how do we get access to that? Just like we learned before, that's just going to be like an attribute, so that we can just call upon that eventually too. So you'll see over here, I'll bring this all in. So you can see we're starting off. We're telling it like, hey, this pay object is an hourly wage of 15, and then we keep. So we'll see off the first one. I'll clear this for you. You see down here, we're just going to go through and we're going to see that, okay, everything's 0. The total hours is 0. And you see how we're just calling the object like we've done before, right? It's nothing different there. The only thing that's getting changed with this class attribute, or the call attribute, sorry, is every time we're now allowed to actually call and use our object as a function. So you can see how we keep just adding that 8 hours. So this is the parameter, 8 hours worked. And you can see how we're just adding up the total hours, right? Just keep tallying it up. And then the total pay is just going to be the hours worked, right, plus the hourly wage, which we instantiated over here. So we're calling self again, like we learned in the last video, and just passing in the parameters, right? So now, and then finally, it as a function does, it returns a value. So finally, then we're just going to pick however much we got paid that particular time, right? So I mean, you can see here, like first week, second week, third week, down here, it's just adding up the numbers. Now, where else you may want to use this? Back to our manager class that we have over here, what you can actually do is, and this is a bit advanced, this is what I was talking about, how it can get a little advanced here. Inside the actual class manager, what we can do is you'll see that we're saying, hey, there's a pay attribute inside the manager, and we're going to set that to the class. So this is a class inside of a class, essentially. It will attach to an attribute. And now you can see down here, we're saying, hey, Michael.pay. So we're almost treating it like a method inside the class, but what we're doing is we're saying, hey, this is actually a separate class, but it's acting and interacting as if it's a function. So you can still start it with values, and it's still going to have values contained within it. So it's a great way to, and again, this is quite advanced. I will definitely have another video for this topic, but just to give you guys some ideas on how and where you can use this, and it can be very useful. So anyways, that's going to wrap it up for today. Thank you for watching.
It's still very confusing for me.
Hey there, this is Dan, and this week I'm going to answer a question that I got from Rio. So Rio had a question around the meaning of underscore characters in Python variable names. So I've put together this little example class, or just a bit of example code that we can play with. And here in the constructor of this class, I'm creating 3 instance variables. So I'm creating the foo variable here, assigning it a value. I'm creating another variable called _bar, and then also I'm creating a third variable called __ or Dunder Baz, because often what we do when we talk about double underscores in Python, we just shorten that to Dunder so-and-so. So in this case, this variable here would be called Dunder Baz. All right, so what I'm going to do now is I'm going to create an object based on this class. Look at my little T object here, which is a test object. So when it comes to variable names, the underscore in Python has a specific meaning. So the single underscore and the double underscore, they both have meanings in Python. And some of that is just by convention. So what kind of everyone believes what an underscore should mean. And some of it is actually enforced by the Python interpreter. With the single underscore, most of it is by convention. So this is generally seen as a hint that a name is to be treated as private by the programmer. So this isn't really anything that's enforced by Python, right? Python doesn't have these strong distinctions between private and public variables like, for example, Java does. But it's more a hint to another programmer that the variable or a variable that starts with a single underscore carries some internal state and is not really meant as part of the public interface of a class. So it's best to leave it alone. Now with the double underscore or dunder prefix, there is actually something that the Python interpreter does. There's some name mangling it applies. So it's going to change the name of that variable in a way that's going to make it harder to create collisions when someone else extends this class. And I know this sounds completely abstract, so this is why I put this code example together here, because what we can do now, we can take a look at the attributes on this object. All right, so now we're looking at the attributes in this object here. And what we can do now is we can look for foo, _bar, and Dunder Baz in this list. And then we're going to notice some interesting changes. So with the foo variable, that just appears here 1-to-1, right? So self.foo appears as foo on the class. Then we've got self_bar, and that'll appear as _bar. So, nothing changed here. It's just a convention, a hint meant for the programmer to say that this is a private variable, or one that you should be careful about changing. Now with the Dunder Baz attribute here, things are a little bit different, because when you search for it here in that list, there is actually no variable called Dunder Baz, but there's one that is called _test, which is the name of the class, Dunder Baz, and this is the name mangling that's going on. So the Python interpreter does this to protect subclasses. So for example, if you were to extend the test class with another class that inherits from test, it does that name mangling to prevent naming collisions. Because when you create another class based on this test class, maybe you want to use the same name, right? Maybe you want to use a similar variable name, and then these two names would collide, and it would kind of create a pretty horrible bug or kind of crappy situation there. So that is why Python applies this name mangling. And of course, this name mangling doesn't just apply to what you can see with the dir function, but it also applies to, well, you're just accessing attributes on the object, right? So I can access t.foo and t_bar, but if I go t.dunderbaz, the object doesn't actually have an attribute called Dunder Baz. And this is exactly what happened there with the name mangling, right? So I can get at that attribute using the mangled name, but this is a really bad idea, right? Like, don't do this. So this is not a good idea, because every time the name of the class changes, the name of the attribute is going to change, and then you're going to have a bad time. Really, the only way to access these quote-unquote private attributes, because they're not really private, as you can see, right? They're just mangled to avoid naming collisions. Really, the only reasonable way to get at them is to access them from the class itself. Because here in the class, every time you go self.dunderbaz, Python's going to apply that mangling automatically, and you don't have to worry about it. It's more a protection from subclasses changing the attribute, or other code reaching into an object and trying to change it. But as you can see, it's sort of a weak protection. It's not really enforced in any way. It's more through that naming change makes it a little bit harder to actually accidentally break things. All right, so this is kind of the short and sweet explanation of what's going on with these variable names and the single underscore and double underscore prefixes that you sometimes see in Python code. If you enjoyed this tutorial and you'd like to see more just like it, then subscribe to my YouTube channel. I put out at least one new tutorial a week. So just hit the subscribe button, and you're going to learn Python as we go along. Cool. So talk to you soon, and happy Pythoning.
Hey guys, how's it going? Today I want to take a look at something that you're probably going to see a lot in Python, and that is this line right here, if double underscore name is equal to double underscore main. So what is this doing, and why do people use it? Let's go ahead and comment this code out, and just right off the bat, let's print out this double underscore name variable. So if I save this code and run it, you can see that I just ran this first module.py, and what I got whenever I printed out the double underscore name was double underscore main. And actually, to make this more clear, I'm going to go ahead and put in that this is the first module's name variable. And let me do a format and pass in that name variable. Now, whenever I save that and run it, now you can see down here, first module's name, and then we have _ main. So what exactly is going on here? Well, whenever Python runs a file, it first goes through, before it even runs any code, it sets a few special variables, and name is one of those special variables. And when Python runs a Python file directly, it sets this name variable equal to main, and that's what we're doing here. We're running this file, we're running this code from the file firstmodule.py. Now we can also import modules. Now whenever we import a module, it's going to set this name variable to the name of the file. So in this case, it's first_module. So let's go ahead and see what this looks like. So I'm going to go over here to secondmodule.py, and I'm going to import first module and save that. And whenever you import a file, it runs that code. And so it's going to come in here and it's going to print out this line. And whenever we ran this line from firstmodule.py, we got first module's name is _main. Whenever we run secondmodule.py and import that module, now you can see that it says first module's name is first module. And the reason it's doing that is because this file is no longer being run directly by Python, it's being imported. And we can actually take a look at secondmodule.py. Let me copy this from first module and let me paste this into secondmodule.py, change this to second. So now I have second module's name, and let me run this. So now you can see that it's importing first module, and first module's name from this file is first module because it's being imported. Second module's name is main because Python is running this file directly. And now this brings us back to the code that we first started with. So now I can uncomment out this code, and now we can see why something like this would be useful, because we can check if _name is equal to main, which pretty much is saying, is this file being run directly by Python or is it being imported? So let me bring this down and cut this out, and I'm going to paste this into this main method here, save that. So now if I run this file, firstmodule.py, I'm running it directly. So I just ran it, and you can see that it went through and it said if _name is equal to main, run this main method, came into the main method and printed out first module's name is main. Now if I go back here to secondmodule.py and I run this code, you can see that I imported first module, but it only printed out second module's name is _main. Now the reason that it didn't print first module's name is because now we have this check in place. If _name is equal to main. Now this, whenever it came through and ran this code,
it's so confusing.
saw that _name was equal to first module and not main. So then it never made it to this main method, and it never printed out this statement here. And just to illustrate this further, I can go into first module here. I can type in an else condition, and then let me take out, I'm just going to take out this main method. And from here, I'm going to do a print statement that says run directly. And then in the else, I'm going to say run from import. Save that. And whenever I run this file, firstmodule.py, whenever I run it directly, you can see that this file was the main method, got run directly. If I come over here now to secondmodule.py and I import first module and run this, you can see it says run from import because it hits this else statement and you can see that it's being imported. So hopefully that clears up any confusion that you may have had about this statement here, if name is equal to main. The reason this is used is because, sometimes there is code that you only want to run whenever you're running this as the main file, and sometimes there's code that you only want to run whenever it's being imported. And one more thing here, if we bring back this main method, and then I'm going to put in a print statement here, I'm just going to put first module's main method, and save that, and then run that within here. And then also, up above this, I'm going to put in a few print statements. That is just, let's see, print, this will be run, this will always be run. So save that, and then whenever I run this, you can see this will always be run, first module's main method. One reason that you might want to put all of your code inside of a method like this, instead of just putting all the code that you want to run down here in this conditional, if you make this method and then within this conditional where it says if _name is equal to main and then run this, what that allows us to do is if we come over here to secondmodule.py and let me rerun this, now you can see that it imported first module and it says this will always be run, and that's because it is outside of that main method. So it's going to get run regardless, even if it's imported. And then second module's name is main. Now with that main method, if we wanted to run that from secondmodule.py, then we can actually come in here and call that directly. So I can save that, and now if I rerun this file, now you can see that it's importing first module, and it's not meeting this condition, so it doesn't run the main method on the import. But then if we want to run that anyway, then we can say first module.main, then it comes in here, prints that out, and then continues on with the rest of the code in second module.py. So I really hope this video was useful and explained this well
understand
enough. If you
when it hits the condition, what does it mean by that? Yeah, this guy is
Hello
really
everyone,
good
welcome
at
back to
explaining stuff. This channel, Kari Sheffer.
into this main method here, save that. So now to this main method, whenever I run it, being imported. So hopefully that clears up any confusion, and sometimes, and then also save that. And then whenever I run this, you can see this will always be run.
Oh, I guess I understand now. It's because name is different than main because the file name is not the main one. I understand. So this is used when you wanna run the file as a script. Only on the first one, I guess. Because if
Now
you
whenever
don't
we
put it, then it's gonna run. It's not gonna run in the beginning, and if you put it, it's gonna run.
import a module,
Without
it's
you
going
calling
to
it.
set this name variable to the name of the file. So in this case, it's first_module. So let's go ahead and see what this looks like. So I'm going to go over here to secondmodule.py, and I'm going to import first module and save that. And whenever you import a file, it runs that code. And so it's going to come in here and it's going to print out this line. And whenever we ran this line from firstmodule.py, we got first module's name is _main. Whenever we run second module.py and import that module, now you can see that it says first module's name is first module. And the reason it's doing that is because this file is no longer being run directly by Python, it's being imported. And we can actually take a look at second module.py. Let me copy this from first module and let me paste this into second module.py, change this to second. So now I have second module's name, and let me run this. So now you can see that it's importing first module, and first module's name from this file is first module because it's being imported. Second module's name is main because Python is running this file directly. And now this brings us back to the code that we first started with. So now I can uncomment out this code, and now we can see why something like this would be useful, because we can check if _name is equal to main, which pretty much is saying.
So this main here in the first time is not referring to this one. It's referring to the name of the file itself.
Is this file being run directly by Python or is it being imported?
That's why it's confusing there.
So let me bring this down and cut this out. And I'm going to paste this into this main method here, save that. So now if I run this file, firstmodule.py, I'm running it directly. So I just ran it, and you can see that it went through and it said if _name is equal to main, run this main method, came into the main method and printed out first module's name is main. Now if I go back here to second module.py and I run this code, you can see that I imported first module, but it only printed out second module's name is _main. Now the reason that it didn't print first module's name is because now we have this check in place. If _name is equal to main. Now this, whenever it came through and ran this code, it saw that _name was equal to first module and not main. So then it never made it to this main method, and it never printed out this statement here. And just to illustrate this further, I can go into first module here. I can type in an else condition, and then let me take out, I'm just going to take out this main method. And from here, I'm going to do a print statement that says run directly. And then in the else, I'm going to say run from import. Save that. And whenever I run this file, firstmodule.py, whenever I run it directly, you can see that this file was the main method, got run directly. If I come over here now to secondmodule.py and I import first module and run this, you can see it says run from import because it hits it.
Oh, so when you don't put it, it runs automatically when you import it. And when you put it, then it puts the check in place and it's only going to run the stuff that you put it there.
This else statement, and you can see that it's being imported. So hopefully that clears up any confusion that you may have had about this statement here, if name is equal to main. The reason this is used is because, sometimes there is code that you only want to run whenever you're running this as the main file, and sometimes there's code that you only want to run whenever it's being imported. And one more thing here, if we bring back
Yes, his videos are very good. Really like his
this main method,
explanations.
and then I'm going to put in a print statement here. I'm just going to put first module's main method and save that, and then run that within here. And then also up above this, I'm going to put in a few print statements. That is just let's see, print this will be run, this will always be run. So save that, and then whenever I run this, you can see this will always be run, first module's main method. One reason that you might want to put all of your code inside of a method like this, instead of just putting all the code that you want to run down here in this conditional, if you make this method and then within this conditional where it says if double_name is equal to main, and then run this, what that allows us to do is if we come over here to second module.py and let me rerun this, now you can see
what series you're talking about. Playlist on his channel.
Imported first module, and it says this will always be run, and that's because it is outside of that main method, so it's going to get run regardless, even if it's imported. And then second module's name is main. Now with that main method, if we wanted to run that from second module.py, then we can actually come in here and call that directly. So I can save that, and now if I rerun this file, now you can see that it's importing first module, and it's not meeting this condition, so it doesn't run the main method on the import. But then if we want to run that anyway, then we can say first module.main, then it comes in here, prints that out, and then continues on with the rest of the code in second module.py. So I really hope this video was useful and explained this well enough. If you have any further questions, feel free to ask in the comment section below. Be sure to subscribe for future videos, and thank you for watching.
I'm gonna check it out. I wonder if he has videos on the other methods. I saw one of these videos about the other methods, but not the ones that I'm trying to understand. The two things I'm trying to understand now is the other methods, and I think, yeah, now I'm probably not gonna research that, but maybe later, how Python is built on C. I'm trying to understand the sklearn library. I was inspecting these things because I want to understand where functions come from when I'm trying to apply machine learning models, to understand the context of each thing. Because later on I want to build my own library, so when I deconstruct this, kind of like slice things through and get to the bottom of them, so I'm able to build it myself. And there's a lot of things here that I started looking at and I don't really understand. It doesn't make really much sense to me how these things are connected, so I'm trying to search for these keywords here and see if I can understand more what's going on. But the more stuff you look, the more stuff there is to study, so. Dunder methods, these all here. They seem to be everywhere. And then, what else I was trying to learn? It's Dunder methods. Yeah, I think that's about it. And then how Python is built, but that I think is a waste of time. For now, at least. Probably later on, I'm gonna research that as well. Big module. I think what I'm trying to search more is how libraries are built. Like if you put yourself in the position of this person that built this, or the team of people that built this library, how do you start? What do you do first? what's the workflow? You know what I mean? But that's really hard to find on the internet because nobody does videos about this. Yeah. And I think that's the best way to learn how to do things better because it comes from the best people probably in the planet. But it's definitely more difficult than the easier stuff. It gets harder to find the information. It's more annoying, let's say. Yeah, that's what I'm thinking, right? It feels like a waste of time, but it's probably worth it, I guess. I think it's just frustrating in the beginning because you don't know anything, so you're kind of lost at each thing you open. Just write what I need and then try to make it less dumb. Yeah. Where do you start though? That's the challenge. I think you start on the init file probably. That would be my assumption. But maybe the init requires you to know exactly everything you're gonna build first. Implementation that works, then you make it readable. Hmm. I don't know about that because it's a different type of problem. And the functions start spreading out. You think of proper modules. Yeah, maybe. The issue is that I don't know the functions, right? That's why I'm doing this study. It's because I'm going the opposite direction, kind of. Like instead of starting with the problem, I'm starting with the solution, and then I want to reverse engineer what was done. You know. Sure, I think it would help. Show you how I design as another type of person. How do you wanna show me that? Uh, yeah, sure. Depends which link, obviously, but I know we're not gonna assume you're not gonna share some crazy stuff. Try yield, finally set config, go to config. Git and paste. Oh, so you're gonna share me a GitHub link and then I'll open up here. So far, what I understand from this file is that is using the config file to import all of this stuff. Then logging.getLogger, I don't know what this does. The name is probably the main thing. Name equals main. Maybe I should research what getLogger does. I don't know if it's from them or from Python. Then here's the version, which is another Dunder method that I guess it specifies the required version of the product. I'm not sure how that works as well. OS environment set default. This picks up the default of the environment, but I'm not sure. OS is operational system library. I used another person's repo as a reference and built my stuff along with it from scratch. Yeah, that makes sense. This would be kind of like a repo, right? It's the same thing, but in a different way. Because the repo has the functions in the library, right? Like all the folders and the functions inside the folders. So it's kind of like the same thing I'm doing. Yeah, don't worry. I'm far from a professional to just a beginner learning stuff. It's task very small. What do you mean by the last word there? Small. Not sure if it's a typo or a word. Simple. Okay. Do you understand what this tries sklearn setup is here? Accept name error, sklearn setup false. I assume that, but this is the thing, it is a Dunder method, but I'm not sure if it's from Python or it has to be made up because it's the name of the thing, but I'm not sure how this works yet. How these Dunder methods are made up. This variable is injected in the built-ins by the build process. Users should enable importing subpackages of sklearn and binaries are not built. MyPy error cannot determine type of sklearn setup. It's made up. Yeah, it has to be right, but how does that work, you know? Like how does Python interprets this? Oh, it has here, I guess. Sees standard error, but this is I guess is for the error. Partial import of sklearn during the build process. Then else. So I guess it declares here, and then this is the thing that runs when it finds this. Imports these things here. Check build, distributor init. Maybe I should be typing this stuff also on the notepad. But it's crazy how much stuff there is to learn. It's just insane. Clone as well. I'm opening Toilet Duck SVO Parse. So do you think it's better to download this as a Git clone or to download directly from the directory? Web, okay. So it's argparse, binas, sc. I don't know how to say this. Struct, it says def main parser equals argparse, argument parser, description, output. Yeah, I don't understand what argparse is. Parsing arguments, but copy route your code editor so we don't get blind, by the way. Yeah. Everybody seems to hate the white background. I'm no exception as well. Yeah, so this code so far, from what I read there, it doesn't look that there's a lot of things that I don't understand really well. It's because my issue, and I'm not sure, probably this is a common thing, but it's not necessarily understanding the code itself of the file, it's understanding how the connection of all the files come together. It's more of the structure of the thing and how they build it so it works on every operating system and make it available as a library. Reads a PlayStation save data file and spits it out fields. So that's why there are parse here. If open args.file rbs this opens the file. RB, I'm not really sure what it does, but this is Python, right? Yeah, it is. I also don't understand what a struct is. Struct. Dot unpack. Other bytes 20 also doesn't make much sense. Implementation split between two modules. So what did you do here exactly? You looked at the first code and then you built this one. Make a new file. Oops. Struct is a sys-style data type, which is just binary data into a clump. I think I've seen this before. On C++, but I don't think I got to read what it does. Two files. So this one and the other one. Parser and structure. Why did you do this? Personal project or? Parser. Oh, got it. So what do you wanna do? Explain me some stuff or walk me through the code? I can see a bunch of things, small things here that I'm not really sure what they do, but I can probably infer what they do based on the way that it is written, but parse the game name, the data, and time for a GUI. Parse from what exactly? Like, try to unpack what do you mean by parse, because I'm not really sure if I understand. I know what parsing means, but it's still not a very. It's still a new concept for me, kind of like. I understand what it means, but I don't really understand how to use it. If that makes sense. So it's on this language, and you wanna make it into another language. That's what it means. So you wanna put it in English. This. I think I get it now. Export the saves as a zip file. Oh, okay. So this is the stuff you've done so far, and then after this stuff here, you want to export it. To export the saves as a zip file. That's the other guy. Hmm. Hmm. I'm not really sure if I'm following, to be honest. What are you saying? You did these two files, and then the other guy did this file, and you want to convert this file into your way, but you haven't done it yet. That's what I think you're saying. No, but I'm not really sure. I think when people do this is because they don't want the variable to change. but I don't remember really well. That's the case. Lexicon set, which is probably a method from Python, maybe. Yeah, so I assume it is what I was thinking about. So from this quick read here, I think this, yeah, the problem is I don't understand these libraries really well. I would have to study them to understand. Arc parse, struct, and bin as. I think this library has something to do with the coding of the HTML and stuff like that in JavaScript. Because yeah, it's from binary to this one, probably. So it's probably a library that translates from this coding to binary. Because this one is the standard on the HTML stuff. Did I put these libraries here? This might be too much to study, honestly. Might be a waste of time. Jar files. So this is the parser and the structure. Which one you did first? Parser or structure? Yeah, this is some memory stuff. Didn't have to use Binance parser first, then reference to the second file. Well, but here you're saying from structures. Dot structures, which I assume is this file here. Let me see how you wrote this. Parser. Yeah, structures. From struct import. So it makes more sense to me that you did the structures first. Yeah, but maybe you did the other one first, then you realized you need some other stuff, and then you put it in this library. That also makes sense. So B is binary, string formatting in Python for binary. The way the code runs. So UTF-8 s equals 4. UTF-8. So here you're making the things equal to the memory size, maybe, that they take. Then def, strip, null, buffer. Byte string, I just use that null to look linear. No, talking about these ones. I guess you're assigning these numbers, these variables to the size in bytes they have. Or no? UTF-8 is a formatting, right? Int 32 is the size of the int. You have to follow them as they come in the runtime. Okay. Parse header, sfill. header equals sfo header.unpack. What does this unpack does? Like the name says, it probably unpacks something, but so I think it unpacks this SFO header. No, it unpacks the argument until the length of the SFO header. That's for data, so I name the integers their appropriate data type. Yes, that's what I imagined. Kind of like you do on C++, but I guess, yeah, Python doesn't have that. So do you know C or C++? It seems like you do because you did that. Sanity check to validate correct test field. Assert, I'm not really sure what it means as well. Not much. Okay. Test if condition returns true. Yeah, it's like it's sus. Assert header dot magic equals. So you're making this, verifying if header dot magic is equal to this thing here, which I don't understand. Where is these letters coming from? Why remainder divided by null? Then return the object. If this equals that, I will let code run, or else I will raise now. Yeah. Where does these letters come from? Maybe it's a little bit harder for me to understand because I lack a little bit of context as well. Even though you explained me the thing, maybe it is just as simple as you explained it there. Parse key table, SVO header, end of the key table is aligned to a factor of 4 bytes. This coincidentally results in no padding between the key table and the data table. Key table, header.key table start. Data key table and header.data table start. So I don't understand where these methods come from. Probably from the structures class. This one, right? Oh, okay. Next table entry structure. This thing. Then you have a length method here. You should never return an active integer since even an empty format string will only result in length 0. So of that structure size. Convert an object implemented in buffer protocol into a named tuple. The buffer must be the same size as described by the format string. What is a buffer object? substring starting at position 6 with length 5, and it doesn't take extra storage space. References a slice of the string. This isn't very useful for short strings like this, but it can be necessary when using large amounts of data. This example uses a mutable byte array. Minimum 0 byte size, slice cuts off this first byte, set the second element in S, which is now also the first element in T. So it's basically manipulating the size of strings and bytes to do something. Reference, look at the link on the top of first file. It shows how the file is laid out. This one? Oh, so this is the... Now I get it. This is how the PS3 is built. The documentation for the PS3. And the structure of the file. Memory does not copy data into a new slice, so I just pass a reference to a chunk of memory to my function instead of copying the bytes every time. Memory view does not copy data. A chunk of memory to my function instead of copying the bytes every time. Variable names from what? From this? I see the SFO there for the structure. Yeah, this is the length thing that you did. So what did you do first? You looked at the documentation and then you started coding? The top or the second file imports? Probably took you a long time to do this. So I guess this thing you're talking about. Magic version key table. Yeah. The index here. So this is the structure for the PS3 thing. Header index table, and it has a small table below, same formats. This one. UTF-8 special mode, not no terminated. UTF-8 character string, no terminated. 32 bits unsigned, which is the variables you did there. Using SVOs generated by the system and are linked to an user. Can be used in any character from the system phones. The null byte is counted as part of the used bytes in len. No, so it's part of the string of the bytes. Always has a length 4 of 4 bytes length and max length, even in the case some bytes are not used, all of them are marked. So what you're doing is translating them into bytes and then converting to another language using the length stuff. It's on the other file. No, it's on that file. Or maybe you don't have lang yet still. Maybe it was on this one. Yeah. Lang map here. Yeah, these types here. Each key is a null terminated F8 string, so we split the entire key table. Not null terminated. It's more interesting to me though is what parts you thought first. Like, did you came up with all of this yourself? If so, you just looked at the documentation and then you tried to see what you needed, and you did it. Renaming the raw integers into variables feels cleaner than using if format equals to. Yeah, it does look cleaner. The question is the execution the same thing? I'm not sure. I don't know, to be honest. Mm. What is yield? I think I'm gonna look this up as well. Increase the offset. Did you look these things up when you're building, or you already knew them when you're doing it? You probably had to look a lot of things up, if I had to guess, because everyone does. The yield keyword in Python is similar to a return statement used for returning values or objects in Python. However, there's a slight difference. The yield statement returns a generator object to the one who calls the function which contains yield instead of simply returning a value. Generator object. So instead of returning a value, it returns a generator object. What's generator object? I shouldn't put this in the library stuff because I'm gonna get confused. I'll put on the other thing temporarily. to look at docs so much so that I keep a local copy. Yeah, relatable. The thing that I'm trying to do is slightly different though. That's the problem. Because I guess I think I know, like I've been through this process as well of looking things up on the documentation and coming up with stuff, researching stuff, but I haven't done the reverse engineering of a library or a project of someone else. Because when you come up with stuff on your own, you are the one building the structure, right, of the project. If you have to look at if you have to look at the code of someone else's structure that has a lot more methods that you don't understand yet, then it's harder to unpack what is going on. On your code, I can kind of understand the things. I don't have the understanding of these keywords that you use here, but I understand the workflow that you did here. But this is different than the other project because it's a lot smaller. Yeah, it's tough. It's very tough. It gets really complex. My GUI code is a total mess because I'm in design process not clean up. Are you gonna build a project with several files and folders? Or do you think this is a smaller thing? Yeah, the most difficult part for me is the connection of the things. I know how to connect files. You just run one file into the other one, but once it starts getting to this Dunder methods and this stuff, I kind of get lost. I think I'm gonna close this. Yeah, there's a couple of things here that I need to study as well. One I think I already understood, which is the yield, and then there was one more thing here that assert, yeah. Assert and then arg parse and this library as well. And struct. I have a folder, so a submodule called parser, which has the parser.py. I sent you as the init.py file. I don't see it. You mean in this file here? Set a program when you call a function that has a yield statement. As soon as the yield is encountered, the execution of the function stops and returns an object of the generator to the function caller. Simple words, the yield keyword will convert an expression that is specified along with it to the generator object and return to the caller. Hence, if you want to get the values stored inside the generator object, you need to iterate over it. Do not destroy the local variables states. Whenever a function is called, the execution will start from the last yield expression that contains a yield keyword known as generator function. Generator function yield. Yeah, I think the things that I need to understand better: generator object, generator function, yield, the other methods, and decorator functions. And that's the stuff that I'm lacking, I guess, in Python as a whole. And classes in general, and how they connect with everything else. In part structures, with dot structures. Yes, but this comes from this file, right? You're just importing the things from this file here. No, then here you have a class that has an init. Yeah, I don't understand this name tupled and struct as well. Simple abstraction to C style structs. Then unpack. I don't have a lot of experience with building classes. The thing is that it's hard to think about a project that I need to write a class. It's hard to know when you need to write a class. Because usually I just default to the easier stuff because it's what I'm used to. So when the class is actually necessary is not very clear. The dot means a relative import, which imports files at that folder instead of a module you install in your system or user data. So it imports the structures file from the folder, or imports from the structures folder. From structures folder, import these files, I guess. Yeah, but here is the things that you're importing. The relative is only possible if a init py file, so Python thinks it's a module. The dot means a relative import. Maybe I should research that as well, even though I think I know what it means, but yeah, clearly it's not clear in my head. Which imports files at a folder instead of a module you install in your system or user data. So instead of going through to the system, it goes through the folder and then picks up the file structures. And the relative is only possible if I init py file, so Python thinks it's a module. What would happen if you don't have the init file? It wouldn't import. Because, yeah, you would import if it's absolute import, let's say. Because I did this and it works. But for this relative import you're doing, then you need the init or it doesn't import. But the difference, yeah, still not clear. Because when I do a normal import, when I've done a normal import, it works, even if I don't have a class or init on the file. And then the files are either on the same folder or other folders. Then I usually the dot notation I use to specify which folder, which directory I'm importing. Use classes when files of Python module. Use classes when code gets ugly enough to confuse you while debugging. Yeah, but that's a blurry line, right? Yeah, it's very subjective. That's the issue. And I guess it comes from experience only. There's no way about it because you have to build big projects in order to know. If you use just parser.py, it would say, oops, I tried to import relatively when I'm not a module. So the structures.py only gets imported if you import the parser folder as a module. Parser folder as a module. I guess I don't understand what a module is really well. That's the problem. Oh, here is build stuff. Do you know if this is a regular thing that people do? These relative imports? Here it doesn't seem like they do a lot. There's also something I saw on some init files of these libraries that they don't really have anything. They just have some weird string or something. Like they don't have any function specified in them. Which makes me think why do they have that file in the first place? But I guess it's just like a requirements file. Or sort of like that. Yeah, like this. You just say function and then there's a bunch of imports here. So I guess it's just like a requirement file, but for libraries instead, because when you download the library, it probably downloads this first and then gets all these modules here, all these imports. Libraries or modules or whatever. What's the difference between a module and a library? It should be the same as a code library, a file containing a set of functions which include in your applications. So this probably will answer my questions. Oh, this is the whole project. Let me read this first. You need to have a good understanding. A Python module is a file that has a Py extension, and a Python package is any folder that has modules inside it. Or in Python 2, a folder that contains an init.py file. But how is it possible that I import files without the init thing and it still works? So I guess it works, but it's not considered as a module by the Python interpreter. What happens when you have code in one module that needs to access code in another module or package you imported? The first Python will do is look up the name ABC in sys modules. Oh, this is a cache of all modules that have been previously imported. The name isn't found in the module cache. Python will proceed to search through a list of built-in modules. These are modules that come pre-installed with Python and can be found in the Python standard library. The name still isn't found in the built-in modules. Python then searches for it A list of directories defined by sys.path. This list usually includes the current directory, which is search first. Because that import can import files in the same directory in Python's installed modules. So the relative import is like you're putting that import in the same files as the syspath files, the syspath imports. Importing a package essentially imports the packages init.py file as a module. You can also import specific objects from a package or module. There are generally two types of import syntax. When you use the first one, you import the resource directly like this. Be a package or module. When you use the second syntax, you import the source from another package or module. Yeah, this two I'm familiar with, but the module subpackage objects such as class or function can also choose to rename the import resource. I can't find the one that you did there. Absolute imports, syntax and practical examples. And if you pip install some module, let's say, and you create two files, a main.py and some module.py. Yeah. If you try to import some module in your main.py file, it will import the package that your pip installed, not the file you need. So if they both have the same name, you're saying. If you pip install some module, let's say, and you create two files, a main.py and some module.py. Okay, you try to import some module in your main.py file to import the package that your pip installed. So the default is to import the pip installed packages. That's why you use relative. Yeah, that's the main reason. Oh, so when you're using relative, you're telling Python that this file is supposed to come from the project itself and not from the system files on the imported packages. So I probably should be using relative imports for the files. Yeah, nice. Thank you. That was helpful. So all the imports on libraries have to be normal, right? Because when you pip install them, yeah, then it becomes a little bit confusing because for example, let's say I have a project that has a folder that has 5 files, and then one of these files uses the other 4 as imports, and then I want to make this folder as a library for someone else to use. I'm probably gonna use relative imports on the file from that one file from the folder, but then use absolute imports when creating the init for the whole project, I guess. In the init file is gonna be like this one that contains the other one that I opened that contains the imports that are gonna be used for the project. Yeah, like here they're using the relative imports. Nice. So this means that this file, and this is a private file, which means it can't be changed. It's not recommended to change this file. Nice, I think I'm starting to get it now. Maybe this was the thing that I was lacking to me. To understand these connections. So from this file is gonna do a relative import of these things. These 3 files. And every file on the library has to be connected to all the other files. It's kind of like a game tree, in a way. Because otherwise there would be no point in having the file in the first place. So there has to be a connection in the source code between all the files. And then these imports also will have connections. Then becomes a giant game tree because it just grows and grows endlessly. So yeah, everything depends on everything else. And because Python is built on C++, then the last level is always the compiler, which depends on the IDE on the operational system. And then the tree gets bigger and bigger. But then that part of that tree has the same parts every time, depending on the framework you are using. Yeah, that's super interesting, actually. So yeah, but the init import things and things import subthings, and the tree goes deeper. The implementation of Python matters. We use CPython. Yeah. Has anyone ever done a visualization of this tree? Because that's the thing that comes to mind. Like, why not visualize the tree and all the functions, the main functions? It seems like it would be a much better way to study the things. Because then you can just see the nested connection of everything. Maybe it's really hard to do that, but... And then every module... I think I saw this on about Linux, where... Because there's so many versions, there is kind of like a representation of the way that is connected. But I imagine to find something for Python like that, it's probably gonna be really hard, or probably doesn't even exist. There's PyPy, which runs a few versions behind, but it's faster because it has a just-in-time compiler. Yeah, I'm probably not gonna use that because at the end of the day, I'm probably gonna use C++ in the future once I learn, which is faster anyway, but Python is easier to implement, so like some other guy told me that gave me this idea, and I think it makes a lot of sense to build things on Python first because it's easier than to deconstruct and build the hard part later. It's hard to do that, that's why you document your code and let programs auto-generate HTML of it. But is it really hard to do that? There must be a way. I don't know, man. Sometimes I think that people make things harder just out of ego or something like that. Because they wanna, how can I say that? They wanna make it seem that it's more difficult, so they seem smarter. But yeah, I don't know. For me, it's always going to think with 1,000 save files, but nobody it's the big of a maniac. So Python is just simple enough. I don't understand what you mean by that, really. What do you mean by it's going to tank with 1,000 save files? Search what get loggers. Maybe I should watch like 300 videos about these things until I finally don't have to even think about it anymore. I just know by second nature. Loads 1,000 save files in a few hundred milliseconds, so it's adequately fast to not freeze up a single thread queue. Then want to mess with threads. How to do that? That's why you document your code and let programs auto-generate HTML of it. Depends on the requirements. I think you misunderstood what I was saying about it. I'm not talking about building anything specifically, like make the nested hierarchy of programs themselves. I'm thinking about just making the tree of connections between things. So instead of putting the code of the whole library, I'm saying like building something that lets you visualize the tree of the libraries and where they come from. So this inspect, kind of like this inspect module, but instead of just showing the source code, showing the representation all the way through. You tried it in Rust, but because it makes everything look hard. Oh yeah, that's the Eagle stuff. There's a slight delay on the stream because of the internet, so. The names people choose as well. It's funny. But it's just human beings, right? I do this all the time as well. Most people probably do it. True. Not subconsciously making things harder than they actually are. And this is the flask thing. Oh, the config is here. I remember. Yeah, here. I'm gonna close this for now. Maybe that's a good idea also to do, like as a small project, to try to do this. But then I would have to inspect the inspect library. It might be a lot more difficult than I think. It could be. Just do it enough to write code you need without a second thought. So maybe there is a way to use this inspect library to create this next nested hierarchy of functions and methods and libraries. Retrieve current values for configuration set by func set config. These are parameter names that can be passed through func set config. Assume finite equals none, work memory. So assume everything is none. If true, validation for finiteness will be skipped, saving time but leading to potential crashes. If false, validation for finiteness will be performed, avoiding error. Working memory equals int default none if set. I think that you gave me a good idea actually. But it might be a waste of time as well. That's the problem. I have to think more about that. Because if there is a simple way to create a function that uses inspect library to see the connections of all these libraries, like to trace, kind of like Google does with linking, with searching the web, but searching for code instead. Then you create a nested linked tree of the functions, and you're able to see where everything comes from. And then it becomes a lot easier to understand how to use things because you know what's the main cause of them, let's say. This might be really interesting as also, actually. Just make a small project that you actually need and add quality of life features to it. I think I might do this project. The only things that I have to think about is it gonna be a waste of time? And is it a lot harder than I thought? And maybe that's why nobody did it. But so far now, it makes sense in my mind that first you gotta understand the common built-in data types and functions, like say name tuple. Yeah, I also need to understand this stuff. But yeah, I'm not sure because these things like named tuple and these sort of things, I think I'm gonna have trouble with them, and obviously I need to learn them, but I'm gonna learn them along the way. To me, the most important thing is to understand the fundamental things, the principles behind the things. Because when you're gonna build the thing yourself, the details are important, but it's more important to understand the connection of things rather than the things themselves. Because I can grab the functions online, and even though I'm probably not going to be good. The challenge is not getting the functions and understanding the mathematics. The challenge is understanding what the best way to translate that into code, given the connectivity of everything. That's what I'm trying to learn, I guess. I like that you need built-in, what you need is a built-in Python function, so always look out for that. Name tuple is just a custom instance of the tuple object, and it all goes back to object. Yeah. Object and numbers. But let's say you have a function that tells you where tuples come from, without necessarily knowing all the code behind it. You can see the connection, it becomes easier for you to understand how it's built. Maybe I'm wrong, maybe it doesn't make sense at all, but get this. I don't understand. This is the generator function stuff. And then finally, try this. I mean, yeah, these methods are really good to know. But I think something like this relative import versus absolute import, is much better to learn than the specific names themselves. I feel like I improve a lot more when I understand things like this than when I understand some specific method. Because the methods might change anyways. And I might create my own. It's more important to understand how the computer perceives the object instead of knowing how to build an object, in my mind. Python objects are cool because they have magic methods. Yeah. String. That's another thing I'm gonna do. I'm gonna search the list of Dunder methods and study all of them to know what they do. And they come from the Python library, which is a set of rules that creates the functionality for them. Makes a difference if you return early. The finally block is run before the method returns. When to use finally, what I need to search. Makes writing code using those objects a lot better. And all of them, all of the isn't this Dunder methods only for classes, not objects? I guess in Python, the curly braces is called a dictionary and not an object, right? So maybe you're referring as Python objects, what I refer as class.
Hello everybody, what is going on? Welcome to another Python tutorial video. In the last video we covered the try except
Everything is an object. Yeah, that. So even strings have Dunder methods? Or a variable, let's say. I'm not sure about that. If it does, maybe it does, but I don't know. Like if I say parameter values, does this here, I can call this dot add? Nice. I didn't know that. I thought these Dunder methods were exclusively for classes. Let's see this. I don't know if this is gonna run because yeah, it is gonna run. Param names. Oh, it's the same thing. But it is equal to a list, right? Maybe we should do a print here. Oh, it's because I have to erase the other stuff because of the imports. Scalar is probably here. So I'm just gonna erase all this stuff. Method wrapper, string of list objects. Damn, that's crazy. What if I type init here? Method wrapper init. Print hello world here. It's weird to me that nobody makes videos about this. It seems like it's the most important thing. Except from the Corey Schaffer guy. But even him is not really in-depth stuff. Or maybe I'm not searching the right way as well. So these are all the Dunder methods of the string. The directory of where they come from. You can't run it because you don't have a save file. It is automatically called when object is created. Corey's guides are quite concise. Yeah, I watched a couple of them, not all of them. I think he's the one that's... His explanations are the best ones that I've seen so far when it comes to this, to Python in general. Do you know how to search the source code of Python? I was having trouble with this before. There's this wrapper thing in this inspect library here to try to find it. Function.wrapper. And then unwrap, inspect.unwrap. I guess wrapper is a dunder as well. It doesn't work here. Because it has to be a function, right? Not an object. When you run length object, it runs object length from a simple perspective. Wrapper is like string, but it is intended for developers, mainly containing vital info about the object. Yeah. But to actually see the code that is built on, the rule set that makes this be what it is. From what I was seeing before is on this lib file, but it's hard to find exactly where it comes from. And I was also not sure if it's the lib root or the lib with the small caps lock. But I guess it's this file here, but it seems like it has a bunch of basic libraries here. HTML, JSON, multiprocessing. Then side packages probably has a bunch of stuff. And this I thought was the things from Python itself, the language, but I'm not really sure. Yeah, this is from the time module, I think. So I don't think this is the code that makes up Python. I wanna find the code that makes up these methods. Yeah, pip install is inside package. And these are all Python files, so it can't be the things that make Python. But the issue is that I'm using the conda interpreter as well. Maybe it's binary skeletons. Where it comes from. Yeah, I know, but I'm curious to look at it to understand how these things are built. Because I don't understand C, but I understand a little bit of C++ already. So I guess it would be interesting. I would learn a lot of stuff. Their GitHub. So they have documentation here. I will just. I'm just gonna look at this stuff first. Have you personally done this yourself? Or not really? Do you think it's worth it spending the time? No, look at the source code. So this is the source code, you're saying. It's gigantic. And in C, I guess you don't have init, obviously. Otherwise, it wouldn't be a Python thing. But this is all in Python here already. So this is the libraries that are built, I guess. I probably have this on my computer already. Let me see if this is the same. Oh, it's struck here. Hmm. There's another folder. It's probably not this. What have I done? What? What happened? Oh, nice. So maybe I will download the documentation. I think it's easier. Because then I already know the file path.
Else statement where the else statement only runs if the exception is not triggered. But what if we always want to run some code in the try and except statement, but we want that code to be somewhat contingent on the outcome of the try and except statement? For this, we use try except finally. So here's a quick example of a try except finally. So we'll say try x equals x plus 3. So that's going to obviously fail and trigger an exception. Except x equals 4 plus 4. And then finally, print do something else with x which equals, and then we'll just spit out the value of x. So try except finally. So now let's go ahead and save that and run that. And we get do something else with x which equals 8. Now obviously if we change this to 3 and we rerun this, it's going to say do something else with x which equals 6. So finally is always going to run, and at least in this case it's going to use 6 for the value of x, but obviously if the exception was called, it would say it would be using 8, of course. But that's not all. For 3 easy payments of $29.95, you can do try except else finally. So to do that, let's do a quick example. You're going to stuff the else statement right here, and we're going to say else x plus equals 1. So again, how does the else statement work? It works when the exception is not triggered. It's as if except is if. So in this scenario, since x is, the try is legitimate, x is defined as 6, it's going to not trigger the except, therefore the else will run. So it's going to add 1, so it's going to spit out x is 7, right? So, well, it wouldn't spit anything out at this point, but x will be 7. Then finally is always going to run, so it's going to actually print out x, do something with x, which equals now, what does it equal? Equals 7. So now, let's go ahead and run that, maybe. And we see do something else with x, which equals 7. Now again, if we said this, x, right? So now try to fail, except will run. Because except runs, else will not run. So x is going to equal 8.
How is this intro videos at 1.5 speed or higher?
So it's going to run, and then it's going to say do something else with x, which equals, and it's going to be 8. So again, let's run this. And sure enough, as we expected,
just get used with to it with time.
Does both, try except finally, but also try except else finally. So anyways, hopefully you guys enjoyed. Hopefully you guys maybe learned something new. If you have any questions, feel free to put them in the comments below. As always, thanks for watching. Thanks for all the support and the subscriptions. And until next time.
Damn, I have a bunch of tabs open now. I think I'm gonna close this one for the project of Fern of Sigma. utils.py also need to study this. So I need to understand these things really well. Maybe I should inspect the inspect library. Maybe I'll learn more trying to do the project there. It seems really interesting to do that and see what happens. But it might be a black hole of information. I already downloaded this. Yeah. What's the name of the movie?
Hey
I
guys, in this
forgot.
video, we're going to explore a pretty interesting inbuilt Python
Inception.
module called inspect, which provides several useful functions which help you get information. Module is
This
a
is the
response
video that I found this stuff on this notebook.
object, and you can use r.content to get the content of your response, right? So we made a request to some import inspect and then inspect dot get members, in which you just pass any Python object. In this case, it's a response object, and then you get all the available property and method names, as you can see here. So here you get a list of tuples where each tuple has two values. First is
Let's see if it works. The problem is that it's not an object, it's a library. So if I inspect the inspector, it's probably not going to show anything. I can run this. Oh, no. There we go. Oh, it does work. Well, classes and methods in Python, so it's interesting to see this other stuff. Yeah, this is the important stuff, I guess. I think that's the core of the thing. I want to see, maybe someone already did this before. But I just don't know how to search for it. What's that? And this is not the stuff that I want. My guess is that nobody did this before. Use a speedrun strat to get a fast time. Your time won't necessarily get faster even if you look at how the strat affects the game script. Yeah, so it depends on the goal you have, right? Because maybe the fastest way is also the slowest way. Because it's a paradigm shift. So maybe you're trying to be the fastest in the current paradigm, but if you accepted that you might be slower, you can achieve a new paradigm in which you can accomplish the same thing but way faster, doing things differently. I think that's why it's not a linear problem. Write a mission or do a glitch setup, which is slower but saves time later on. Yeah, the question is, how do you know, Red, if it's a waste of time or not? I think both perspectives are valid. It can be a waste of time, but it can also be really interesting. I think it's not just for me, it's for everybody that learns this stuff. What people have difficulty with is not understanding the language, is understanding the connection between things. This is the most important part. And to see the connection, I think it probably would help a lot. But it's just really strange to me that nobody did this before. It seems like an obvious thing to do. We can use pretty prints here, so it's easier to see. Preprints. Yeah, the thing is that it's extremely difficult because there's so much stuff to learn. It's not like a small library. But maybe just this get source that I need. See you, man. Thank you for the help. The module thing really helped. Find source. That doesn't work. Spat, not get file. It's gonna be on the library and site packages, probably. So lib inspect by. The anaconda lib inspect by. It shows the absolute path, not the relative path for the file. But I guess I can just look at site packages. Probably gonna be here somehow, somewhere. Maybe on Conda. No, I don't think it's gonna be on Conda. Let me see there. That doesn't show up here. So I think I'm gonna navigate to the file path. So Anaconda lib inspect.py. Maybe we should open this on the another window. It's a file, not the. Anaconda lib. Here. Get useful information from live Python objects. This module encapsulates the interface provided by the internal special attributes. In a friendlier fashion, it also provides some help for examining source code and class layout. Here are some of the useful functions provided by this module. This module is class, is method, is function, is generator function, is generator, is traceback, is frame, is code, is built-in, is routine, check object types, get members of an object to satisfy a given condition, get source file, get doc, get module, get class tree, get arg values, get full, auto frame, screen frame, stack. So this imports a bunch of libraries as well. OS system, tokenized types, warning, functools, built-in, operators, collections. So the thing I have to think about is where I think what I want to do is actually do the import stuff. Seems the simplest. The other stuff is really a lot harder. So I probably need the OS library because if I want to find the flow of the imports, I need to use the operational system. And then I want to find the flow of imports and I want to put them, represent them in a visualization tool. So I know the connection between things visually. So I think what I can search for is how to build trees using Python. How to build visualization trees. It's probably better to watch a video first. Then I think I'm gonna close this stuff. So yeah, I think the first thing I'm gonna do is this actually. Don't forget about studying this stuff. Because I'm probably gonna learn a bunch of things while building this project. Or trying to build, because I don't know if it's possible or not. I think it probably is, but I might be wrong. So I think I'm gonna do this before I study the libraries, and then I'm gonna also watch a bunch of videos about these topics here. Generator object, generator function, yield, Dunder methods, decorator functions, relative import, buffer. And this is the next thing that I'm gonna do, probably on stream, until I'm able to do it. So how to visualize trees in Python? Maybe game tree is better. No, here. So there's already code for this. So I'm gonna create a folder for this as well. Let me do this. And it's gonna be module finder, the name. I'll be right back actually. I'm gonna go to the bathroom.
Today, I'm going to tell you how to use
Another thing that I have to search for is because I remember seeing something that said that not all modules are downloaded in your computer when you import a package. So understanding imports in init file and important package. There's probably not going to be a video about this, but this also looks interesting. probably already understand, when you import a module, the interpreter creates a new namespace and executes the code of the module with the new namespace as both the local and global namespace. When the code completes execution, the module name or the name given in any else clause is bound to the module object just created within the importing namespace and recorded against name in sys.modules. So I guess that from what I remember, namespace is just another way to say it's similar to a library in C++, but I'm not. Maybe I should search for the difference between namespace and a library.
Hey, what's up guys? My name is Eterno and welcome back to my C++ series. So in the last video, I explained why I don't like using namespace std. If you guys haven't checked that video out, definitely do so. But I haven't actually talked about what namespaces are in this C++ series, and because in that video I specifically wanted to talk about the standard namespace and why I don't like using namespace std. But today we're going to be talking about what namespaces are in C++, why they're useful, when I wouldn't use them, why they exist, and all the different things that we can do with them. So if we jump right into this is the code that we had written in that previous video where we talked about why I don't like using namespace everywhere and all that kind of stuff. Let's talk a little bit about what we actually see on the screen here and how we can further extend our usage of namespaces and why namespaces are actually used and necessary. So over here, we essentially have this issue where we have two print functions. Now they do have different signatures. One of these takes in a string, one of these takes in a const char. But if we kind of revert to maybe both of them taking in a const char, so if I change the string one to actually take in a const char pointer like so, we kind of may have an issue if we weren't using namespaces, because these functions are identical. If I just kind of comment out this namespace apple line of code here in the orange one as well, suddenly we have a little bit of an issue. If I try and, I'll fix up this error as well, if I try and just compile this by hitting Control F7, you can see over here that I get an error because it's telling me that this print function that takes in a const char pointer already has a body, because I have two symbols with the same name and they're identical symbols. Now when I say symbols, I'm talking about things like classes, functions, variables, constant, that kind of thing, right? So we have in this case two
It pretty much creates a scope for the functions. That's what it does.
functions called print, which take in const char pointer and return void. They have the same signature. So these two symbols are identical. We can't have two identical symbols. That's a linking error and potentially a compilation error in there if they're actually in the same file. So how do we fix that? What if we do want to have two print functions? Or what if we use another library that has already defined a print function, but we want to have our own print function? Now back in the days of C, and in fact that still is a thing, C doesn't have namespaces, which is why if you would have noticed in the OpenGL series as an example, we're using a library called glfw, which is an OpenGL kind of windowing and context library and input and all that kind of stuff, right? But the point is glfw is a C library. It's compatible with both C and C++. Because it's a C library, they can't use namespaces, which is why if you notice in that series, all of the code that we write that has something to do with glfw begins with, like literally every function starts with glfw and then like the function name. For example, glfw init or glfw create window. All of that stuff has glfw literally prepended to the front of it. With OpenGL, it's kind of the same thing as well. We have GL and then the symbol name. So like GL begin, GL end, GL gen vertex buffers, that kind of thing, right? We have the actual name of the library or some kind of ID embedded into the function name. So in our code,
You can search
that would be the equivalent of if I had literally
you can search for scripts that says what modules, what libraries are imported
written something like
inside
apple
another
print,
script.
right? And orange print. And then now you can see that, oh, okay, these two functions are different because this is like the apple print version, this is the orange print version. And that's actually what C libraries tend to do, because they can't just, I can't make a function just called init, because init is such a common name. What if, if every library was to just name their functions init, then you could never use those libraries together without having to modify the source code. So what they do usually is just kind of prepend the name of the library to it. So glfw init. And that works because, well, it's a fairly unique name, right? glfw init. Okay, cool. That's specific to that glfw library. Now in C++, instead of us having to do all this, we have namespaces to solve that issue. The primary purpose of namespaces is to avoid naming conflicts. That's why they exist, to avoid naming conflicts, okay? That's it, sort of. Just if you're getting confused by why namespaces exist or why they're being used, it's because of naming. We want to be able to call symbols the same name
in different contexts. So if we go back here into Apple print, instead of having this, what we can do is enclose this symbol in a namespace. In this case, what we write is namespace, the name of the namespace, and we want to use the one from Apple. We just type Apple : and then print. This : is essentially like a namespace operator. So what you do is every kind of namespace that you, as you drill down into a namespace, you just put a : and that is what, I guess, enters into that namespace.
Everything makes sense now.
Or allows you to call things from that namespace. The same thing applies to static functions, I guess, or symbols in classes, and like methods in classes and all that stuff. A class is kind of like a namespace. It is a namespace of its own, which is why if we're accessing like an inner class inside another class, or like an enum, or, you know, like I gave the example of like static functions or even non-static functions in some cases, we use : So that's what the : kind of means. So this double colon is used to get the print function from the Apple, and if we were to run this, we would just get hello printing normally. If I want to call the orange one, obviously I type in orange. Now that whole using namespace thing that we talked about in the last episode was just a way to not have to write this kind of apple or orange kind of prefix. So instead of having to do this, what we can say is that actually we're using namespace apple, which means that basically import everything from namespace apple as if I had never specified it as a namespace. So in this case, print will be used from apple. If I want, I can change it to orange. I can also say, if we have multiple things in here, like we have print and maybe print, I don't know, print again or something. If I have multiple functions, maybe I don't want to use print again from orange. I just want to, sorry, that's an apple. Let's go to using namespace apple. Maybe I don't want print again. When I put this using namespace, I don't want to use print again. I still want to specify maybe which print again I want. I just want print to be imported. So to do that, we can just write using apple and then the function name print. Okay, that means that we're going to take this from that, or, you know, something confined to the declaration inside that. It does all of the helpful work that namespace.
I think I already understand now. Struct or even a static class other than using struct is the other thing that I have to look for. I think I wrote it down here. Oh no, didn't, so. So this is the file for the inspect module. Imports these things, lean cache, intertools, enum, collections, disk, built-in functools, warning, types, token, tokenize. From collections, import named tuple. It's another thing that I have to search for. Create constants for the compiler flags and include code. We try to get them from this to avoid duplication. Mod directory equals global. So globals, I guess, is an object of some of these things here. It's a function, but I don't know where it comes from. Maybe I can use the inspect thing to search where it comes from. For KV in this .compiler flag names .items mod dict equals this. C include object .h. Is module object. Return true if the object is a module. Module object provides these attributes. Cached path name to byte the compiled file. This is very useful to know as well. Yeah, I think by understanding these things is actually really good. By trying to do this project, because I'm gonna learn a lot about the functionality of things behind the scenes. It's very useful. Documentation string file name missing for built-in modules. Return is instance object, which is passed, the thing that you're gonna pass. Types.module type. I don't understand where this comes from. Def is class. return true if the object is a class. So doc module, name of module in which this class was defined. Object type. Name of module in which this class was defined. So you're gonna pass a class and it's gonna return the name of the module that was defined. So it's gonna return the name of the file where the class exists. It's good, true. This method return true if the object is an instance method. Did I skip the one that is module? Yes, it's this one. So this one is the one that I'm interested. Return true if the object is a module. Module object provide these attributes. Cached, path name to byte compiled file, doc, documentation string, file name, missing for built-in modules. So what I need is to do this on a loop or a recursive way, so that every time it finds a module, it finds the modules inside of the module and creates the link of hierarchy between them. Cached path name to byte compiled file. But this still doesn't answer the question of how I'm gonna know which modules are inside of that module. I can look, maybe I can, maybe there's a way to look inside of the object and search for specific names. So maybe that's something that I should write. Ouch search. So the first step is pick a module, which is going to be the same function here. Then I need to understand what types.module type is. And that's the issue. Because these things here, it's things like this that make this difficult, because it doesn't seem like it has any connection to anything, and it starts to understand where it comes from. I guess I'll keep reading. Is method return true if the object is an instance method? Is method descriptor return true if the object is a method descriptor, but not if is method or is class or is functions is functional too. This is new Python 2.2, for example, is true of init.add an object passing these tests as a get attribute but not a set attribute. But beyond that, the set of attributes varies. Name is usually sensible and doc often is. Methods implemented via descriptors that also pass one of the other tests return false from the isMethod descriptor test, simply because the other tests promise more. You can count on having the func attributes, etc. when an object passes this method. If is class object or is method object or is function object, mutual exclusion return false, TP equals type object. So this all is from this is method descriptor. So it checks to see if it is any of these three. If it is, returns false, otherwise returns type object. Otherwise makes TP equals type object, then returns has attribute TP get and not has attribute TP set. Then verifies that has get and not set. Returns that has get and not set. Is data descriptor. Data descriptors have a set or a delete attribute. Examples are properties defined in Python and get sets and members defined in C. Typically, data descriptors will also have name and doc attributes. Properties, get sets, and members have both of these attributes, but this is not guaranteed. If class is any of the three, false, and has attribute set or has attribute delete. If has attribute types, member descriptor type. See Python and equivalent. Def is member descriptor object. Return true if the object is a member descriptor. Member descriptors are specialized descriptors defined in extension modules. Turn is instance object types member descriptor type. Else other implementations is member descriptor. Member descriptors are specialized descriptors defined in extension modules. Is get descriptor. Looks like the same thing as the other one. So, but this is member descriptor type, this is get set descriptor type. This function, return true if the object is a user-defined function. Function objects provide these attributes: doc, name, code, defaults, globals, annotation, key, defaults. So now I understand how it works. Everything in Python is an object, and depending on which object it is, it's going to have different Dunder methods, and that's what separates them from each other. So a function is different than a string because of the Dunder methods that are evoked when you use each of them. So understanding the Dunder methods is probably a key thing. Should be good at developing things. Function objects provide these attributes: doc, documentation string, name which this function was defined, code object containing compiled function bytecode. Yeah, this is really good. Good stuff. Defaults, tuple of any default values for arguments. So this returns the arguments of the function. Globals, global namespace in which this function was defined. So the global scope of the function. Annotations dict with parameter annotations. Keyword defaults, dict of keyword only parameters with defaults. And this returns the keywords. So I guess did I put the defaults here? No. Maybe I should do a separate file for this as well. I'm gonna put on this one momentarily, but I'll put it on another file later. That's the issue. So I'll do it like this. Probably can do it like this. Then I'll copy here. Types.function type. I guess this is probably a method from Python as well, because it has it on all of them. So I guess what this is doing is just returning the type, that object thing that returns when you run the inspect library. As code flag, return true if f is a function or a method or functions.partial wrapper wrapping a function whose code object has the given flag, setting its flag. Always method f equals f.func. This is good to look it up as well. Return false. Def is generator function. Return true if the object is a user-defined generator function. Generator functional objects provide the same attributes as functions. See help is function for a list of attributes. Def is coroutine function. Return true if the object is a coroutine function. Coroutine functions are defined with async def syntax. So asynchronous functions. Is async get function. Asynchronous generator functions are defined with async def syntax and have yield expressions in their body. That's interesting as well. Is async gen, return true if the object is an asynchronous generator. Is generator. Generator objects provide these attributes. Either define just part iteration over a container. Close raises a new generator exit exception inside the generator to terminate the iteration. G code, code object, G frame, frame object are possibly none once the generator has been exhausted. G running such one when generator is executing, 0 otherwise. Next, return the next item from the container. Send resumes the generator and sends a value that becomes the result of the current yield expression. Throw use true raise an exception inside the generator. Return true if its coroutine is variable. Return true if the object is a traceback. Frame objects provide these attributes. F back, next outer frame object, this frame's color. fbuilds, so frame objects. How long is this thing? Code objects provide these attributes: core arg count, number of arguments, not including these ones, or keywords, only arguments. Full code string of raw compiled bytecode, tuple of names of cell variables, tuple of constants, file name, flags, free var, bunch of stuff. So it's codes basically to see if it's code or not. It's a code object. A file in which this code object was created. First linear number of first line in Python source code. Bitmap 1 equals optimized to new locals. 4 equals args 8 arg. 16 nested, 33 generator, 64 no free, 128 coroutine, 256 turbo coroutine, 512 async generator. Tuple of names of free variables, number of positional only arguments, number of keywords, keyword only arguments. Encode a mapping of line numbers to bytecode in this. Name of which this code object was defined. Tuple of names of local variables. So I guess this is the way that Python defines whether something is code or not, in order to differentiate from comments, I guess. Is built in. Doc name self. Instance to which a method is bound or none. So the expression is used there was type dot something as well. Get members. Optionally only return members that satisfy a given predicate. Dynamically to list. This may result in a duplicate entries if, for example, get attributes. So I think I'm gonna have lunch soon. I'll be right back. Yeah. So I'm gonna have lunch. Then I'm probably gonna come back later. Then I think I'm gonna do this project until and then I'm gonna come back. So instead of, I'm actually gonna study the libraries as well. But I think it's gonna be interesting to try to build this project and study these things along the way. I'm gonna watch, when I come back, I'm probably gonna watch videos about these things here, all of these topics. Then after I do that, then I'm gonna try to build this. And the goal is to build something that allows me to visualize the connection between libraries. And if I'm able to do that, then I think it's gonna be much easier to study all the libraries. So my idea is just to create something where kind of like inspect, where I can just do that inspect dot get source, and then I put the name of the library here, sklearn, and then it will show me a tree, a visualization tree of all the connections between libraries that sklearn uses and where they're coming from. So the init file is gonna have all of them, which are gonna create this tree aspect, and then each one is gonna have their own connection. And hopefully I wanna be able to build something that allows me to jump from one to the other, so I can study the flow of them, to see how the code connects with itself. But might be a lot harder than I expected. I'm not sure if I'm gonna be able to do it. I might just give up on the middle of it, but I think I'm gonna learn a lot by trying. So I think it's worth it. So yeah, when I come back, I'm gonna watch videos about these topics here. So yeah.